Video we're going to look at inverse proportion. Now I urge you to have already watched the one with direct proportion, and in direct proportion, for direct proportion we found that as a letter such as y got bigger, so x also got bigger, and this is direct. And also in that video we looked at the starting point for the equation for this, which would have been something like y equals kx, and that's fine for direct. Now in indirect, let's imagine that the x again gets bigger. As the x gets bigger, the other variable comes down, and that's inverse proportion. And just to give you a couple of graphical examples of that, here we are. As x gets bigger, y gets smaller, and it doesn't have to be a straight line, so as x gets bigger, y is getting smaller. Now in the direct, y equals kx was my starting point. In the inverse, it's y equals k divided by x. Remember, the k is a constant number for the whole question. The y and the x are variables. They will change. So let's go and have a look at a couple of questions. Okay. X is inversely proportional, so I've got the keyword here which is inverse, and it's just x and y. So it's inversely proportional to y such that when x is 80, y is 20. So y equals k divided by, let's make this x to begin with, that's my starting point. Now y is 20, k divided by 80, and if I work this times both sides by 80, I get k is equal to 20 times 80 is 1,600. So k is 1,600. So my equation is y equals 1,600 divided by x. So now I can use this equation to work out the rest of this. So find the value of y. If x is 200, so that's just going to be the k number divided by 200. So that's going to give me y equals 8. And this one, the different way around, 5 equals 1600 divided by, I'm trying to find the x number, so a bit of algebra is going to give me 5x equals 1600. And I've got up here, I'm going to divide both sides by 5, so 1600 divided by 5, and again I'm just going to use my calculator to be on the safe side, so x is 320. So again, that starting point is different because it's the inverse, it's y equals k over x. Now let's just take it up a notch, have a look at another question, and remember, we don't have to have x and y, we've got a and b, and further we've got the square root of b, and we've got the magic word inverse. So I'm going to start off again. A equals k divided, instead of just putting b here, I've got the square root of b. But again, that starting point is to have the k at the top and the other variable on the bottom. A is 1. B is the square root of 5. Now, that's a bit of a weird question. So that's going to give me square root of 5 times 1. So k is the square root of 5. And I'm actually just going to leave it as a square root of 5. So now my equation is a equals root 5 divided by root b. And I think normally you'd get a nice normal or constant, maybe a integer or a whole number value. So find the value of a when b equals 15. So a equals square root of 5 divided by the square root of b, which is 15. So that's a very simple one to work out. We're just going to do square root of 5 divided by the square root of 15. Okay, it gives me the number here. Remember, if I press the FD button on this calculator, it gives me a is 0.577. So some nasty numbers here, but we can still work with them. Find the value of b when a equals 5. So 5 equals root 5 divided by b. So I make this 5b equals root 5. And now divide both sides by 5, so I get root 5 divided by 5. Again gives me this number, and if I press the FD button, I get b equals 0.447. So some nasty numbers, but the principle's the same. Again, we're starting with this a equals k over root b. Try and remember the difference between the direct and the indirect proportion. With direct proportion, there's my starting point. With an inverse, there is my starting point.